Hi folks, good morning. So we're going to start by going over homework answers for graphing. So I'm going to try to put this as like a full screen and you let me know if you can see it. If I turn the lights off. Can you see this? Or is that not? We'll do it in pieces. So the x-intercept, the x-intercept, y-intercept, we'll talk about in a sec. Is there back all set? Good? Yep.
Yeah, I didn't do the y-intercept.
No problem. I just want to see the graph.
Yeah, the graph.
Good. Good. And then your ID makes a great ruler, so go ahead and use a ruler for that. Good. Good.
Really weird music. No. Or really weird what?
Awesome. Thank you. Full set? Full set? Yes. Both? Yes. Go and work on that now. Let me know when you find it. Let me know when you find it. Full set? Yep. Good? Full set? Yes. Good?
Mine is wrong, like, completely.
Completely? What? All right, let's talk about it.
Well, it's not wrong completely, but part of it.
All right, so let's first talk about x-intercepts, y-intercepts. So last night, many of you successfully just identified it from the graph, but think back to your Algebra 1 days. Remember when you ever graphing linear functions by intercepts? To find the x-intercept, let y equal 0. To find the y, yeah? No, maybe. So let's reason on this real quick, okay? So don't just copy this. I want to talk about it. So let's say I have a graph, right? Like so. For a value to sit on the x-axis, what has to be 0? So for x-intercept, let y equal 0, and then you solve for x. Now think, if I want something on the y-axis, which would be a y-intercept, what do you not want to have? Right, x has to be what for your point to sit right here? So for the y-intercept, let what be 0? And that's what this is showing you. So for the y-intercept here, this is y-intercept, let x equal 0. For the x-intercept, what is 0? So take a second. We have the space. Work on it. Let me know how it goes. And you can check your answers as you work. If anybody would like to see one done, just let me know. Yes. We take what's in the bars and we set it equal to a positive 1/2 and a negative 1/2. Subtracting 4, how could you write 4 in terms of halves? What divided by 2 equals 4? 8. So so this is like saying minus 8 1/2 minus 8 halves is negative 7 halves. Or negative 3.5, whatever works. Do we match on the first two? Not done yet? And we're good though. Do you want me to work through one or you just need a little more time? Yes. After? Yes. Okay. So of the 4, work on all the 4, each of the 4, and then let me know which one you want to see. Did you find it? Do you need another copy? On the wall, third folder. Up top, behind the mini golf, right? How are we doing? How'd these go?
Oh, I was alright. I don't know how to do this stuff. When the X gets replaced by
Okay. So can I briefly touch your pencil? Do you need an eraser?
yeah.
You can be checking in with a neighbor on this too. So when we're actually doing this evaluating, there's no -1 or -1 like this. We're just straight up saying, what's f of 0? So what is the absolute value of 4?
4.
4. So this becomes -2 times 4. plus 1. Negative 8 plus 1. Right?
Yeah.
I'm sorry, negative 8 plus 1, not 7. So 0, negative 7. 0, negative 7. And I would give it a title. This was, letting x equal 0, that means you're finding the y-intercept. Down here, what are you finding? So now that you have a value over here, that's when you be subtracting 1. Right? Good question. You're welcome. Questions? We're getting the feel of it? Let's talk. Which of the 4 would you like to see as an example? Which, give me 1, 2, 3, or 4. The principle of it is the same. It doesn't matter what problem. 1? Number 1? Number 2? Who votes for number 2? I got 3 people. 4 people. Number 3? 2 people. Number 4? 3. Number 2, 1. But how about this? I will put a video up of calculating the intercepts for all of them. But for right now, we're just going to talk about number 2. So number 2 says f of x equals 1/2. Okay, so I highly recommend giving your work a title. So for the x-intercept, what are we going to let be 0? It doesn't matter which one we do first, but writing this down can really help. It literally is like a set of directions, to the right, to the right, to the right. So this is going to say, we're going to do what we said, let y equal 0. So 0 equals 1/2 x minus 3 plus 5. What am I going to do first to solve this? Good. Subtract 5, subtract 5. So I got negative 5 equals 1/2 x minus 3. Now what? How do I get rid of this 1/2? Multiply by what? 2. The reciprocal of 1/2 is 2 over 1, or 2. So that gets rid of the 1/2, which ends up having us with x minus 3, still an absolute value, equals negative 10. Ooh. Think back to yesterday. What did we say happens when we have this? What's the word for that? So how many x-intercepts are there? None. Does your graph show that? Look at your graph. Let's talk y-intercept. For the y-intercept, let x equal 0. Can't draw straight lines today. So that will look like f of 0 equals 1/2. Now wherever I see x, we're going to plug in a 0. Now what? What's this? 1/2 of 3 plus 5. So what's the ordered pair for the y-intercept? Good. Just going to move this comment over. So no solution, no x-intercepts over here. But we definitely have a y-intercept at 0, 6.5. Again, you let x be 0, which is how I remember that it's 0, comma 6.5. How about 3 and 4? How'd that go? We're good? Does anybody want to see your 3 or 4? Or is this the only one? 4? Four says f of x equals 3/2 x plus 1. Tell me what to write. What title am I going to give my work? X. You want to start with x-intercept or y-intercept? Okay, so x int, let what? Good. Let y equal 0. That one little sentence really helps. So it's going to be 0 equals 3/2 x plus 1. Is there anything that needs to be added or subtracted over? Nope. How do we clear this fraction? Multiply by 2/3. So 3/2 times 2/3 is what? 1, which is why we can cross these out. What do I end up with on the left side? Now, if this was a number, we'd be saying, okay, now we're going to set x plus 1 equal to positive 1 and negative 1, or x plus 1 equal to positive 5 and negative 5. Is there such a thing as a positive and negative 0? No. So how many equations do we actually need to set up for this one? Just one. Does your graph reflect it only having one x-intercept? Where's the x-intercept going to be? Only one. So now for our, what's on my other title going to be? Y-intercept. Good. Let x equal 0. So let's do that. So it's going to be f of 0 equals 3/2 times 0 plus 1. Yes, was there a question? No? Okay. So this is going to be 3/2, and then what do I have inside the bars? Just 1. The absolute value of 1? 1. 3/2 times 1, 3/2, which equals 1.5. Check your graph. Is your y-intercept at 0, comma 1.5? Halfway between 1 and 2? We're good? Yes. Yeah, see? Negative 1, comma 0. Good? So I would highlight, in your note, on this worksheet, I would highlight this so that this sticks out to you in your notes. Everywhere where you wrote these titles, we want to remember how to do this. Yes. So I'll come full circle to the golf question. I just want to make sure we have enough time to talk about writing. Yes, coming. Nicole? Yes.
Why would this be no solution? Well, okay, well.
Because anything in absolute value bars, will it ever equal a negative number? Ever, ever, ever? No. Like the absolute value of a negative number kicks out what? Like what's the absolute value of negative 5? What's the absolute value of 5? So no matter what you do in here, in these bars, it'll always come out to be a positive result. You will never get this to equal a negative. It's impossible. Because to get an output, you got to take the absolute value of whatever's inside. The only two options for what's inside is positive or negative, and either way, it always comes out to be positive. Right? Good question. Yes.
I keep messing up my graph. Guess I was thinking.
So we have to remember the question. My parent function is y equals a times x minus h plus k. There's a built-in negative right there. So if I see a positive, it means a negative 4 was plugged in right there. That's the key. All right? Good question. You're welcome. All right, folks, writing absolute value functions. Now, we are going to do a little bit of board notes, but you can actually just do it right on this worksheet if you choose to, or if you like to put it back in your notebooks with your other absolute value notes. That works too. Whatever makes you happy makes me happy. Yes. What would you say if I said me not being in this class makes me happy? I would say it's Happy Friday, so that wish is granted tomorrow. Okay. All right. Yep. Okay, let's start working on our handout. It is only 2 steps. Let's talk about our first example. So So the easiest absolute value equation is just this. What is this called? Very good. Parent function. There is no shifts of any kind. So let's see how we could build this equation from this graph. Where's my vertex? And now from 0, 0, if I were to count the slope of the right ray, how would I count? Up 1, and then where? Right 1. What is up 1? Positive or negative? Positive. Right 1? So I have H, I have K, and I have A. What's the general form again for an absolute value function? F of x equals A. So if we were to fill in the information we just identified, this would become f of x equals, do I need to write the 1? I could. Your choice. For the sake of detail, we will for a moment. But what would all of that simplify to? Yeah, we said we don't need to write the 1, and then x minus 0 is just x. Yes?
When you're doing the slope for the equation, you always count the one that's on the right, because it would be a negative one if you counted the line to the left.
Yes. And that is connected to how we would write this as a piecewise function. So let's make a connection. Yes?
Wait, but what about the other slope? Would you do negative 1?
That's what we're going to talk about. So they both are bringing up a point that connects to this title of how do we see this as a piecewise function? Because if I chose to see it that way, how many pieces do I have here? So piece number 1 I'm going to call it the right side. Keep. Absolute value. So for piece number 1, we're going to keep the absolute value the same and simplify. Now, with a parent function, you don't get more basic than that. What it means is we're just literally going to drop the bars, with A still being a positive 1. Because for the right ray, what was the slope? 1. So if we let that be for piece 1, that's going to be f of x equals 1 times x is just what? X. So that is the expression for the first piece. Piece 2, what are we going to do? What does it say to do? Make what negative? Which is exactly what they were saying. What's the slope of that left ray? Yeah, up 1, left 1. So for piece 2, A is going to be negative 1. So that's going to become f of x equals negative 1 times x, which equals what? Negative x. So I have the expression for each piece. Where the domain comes from, because for a piecewise function we always have a domain restriction, that's directly connected to h. What is h in this graph? So when x is greater than 0, is that piece 1 or piece 2? Only one person sure? On this half, this ray, is that when f of x is x or negative x? Good. So, not h. X greater than or equal to 0? And what will this automatically be then? So that h value directly gets me my piece. And then for formality's sake, we can put this together as a piecewise. So f of x equals our big curly bracket x when x is greater than or equal to 0, and negative x when x is less than 0, and we're done. So let's practice just with an equation. Look at the next one. No graph, just an equation. If I were to graph this, what's the vertex? Yep. What's A? Good. So now we're going to talk piece 1, piece 2, using the steps we just talked about. What are we going to do in piece 1? Read your notes on piece 1. What do we do for piece 1? So we're going to leave A alone. Leave it just as it is. And we're going to simplify this. So how would I simplify? What would I get? Yes, these are no longer absolute value bars. These are now parentheses. So we're going to simplify, distribute the negative. What do we get? Negative x plus 3 minus 2. Combine like terms. This is negative x plus 1. So that's piece 1. We left A alone, left A however it was given to us, and we just solved. What are we going to do for piece 2? So what would be the opposite? Positive. So tell me what to write right here. Yep. Do I actually need these parentheses? Is there anything to distribute? No, so this just becomes x minus 3 minus 2. So it's x minus 5. Now, up here, we did identify H, K, and A. Based on A, how is this graph opening? Down. So I do recommend, just draw yourself a quick sketch. And we can get the vertex on there, too. Which of these two values will matter for the domain? Go back and read. H or K? H. So highlight H. The piece that you leave alone, do you know what I mean by that when I say the piece you leave alone, where we didn't change A? That's what I mean. The piece you leave alone, I'll put leave alone in quotes, meaning we didn't change A. The piece you leave alone, meaning you didn't change A, will always be the right ray. I know, not cool. So if we look at this, right, what kind of slope does this piece have? Check out piece 1. What slope does this have? Negative. So when I'm talking about 3, does this apply to when H is greater than 3 or less than 3? We're going left to right, right? So if you were to put this on a coordinate plane, I don't want to draw it like that because this technically is in quadrant 3. Remember, when we're talking the x-axis, right? Would this be going greater or less than 3? Greater. You follow what I'm saying? If you were, let me see if I can move this because I want it to be a correct. So 3, -2 would be like, in quadrant 4, right? So if I asked you for the domain of this right piece, would you say x greater than, this is 3 on the x-axis, right? Greater than 3 or less than 3? Greater. That's what I mean. So that's how we know this is for x greater than or equal to 3. And then by default, this is x less than 3. Don't overthink this. Think back to domain and range of piecewise functions, right? If I asked you, I'm going to make this one yellow. This is piece 1. Oops, that's blue. This is piece 1, right? This is the expression that goes with piece 1. And that's the right ray, right? Decreasing slope, I have a decreasing line. Way back, like 2 weeks ago, if I asked you what is the domain restriction on this ray, I would read it left to right, yes? I would say 3 and bigger, or x greater than 3. X greater than 3. Just looking at domain. We've been doing domain all year. It's just domain like we've been doing domain for every other graph. Yes? Yes? We'll practice another one. Oh, let's finish writing the function. So the final step, it's more of like a formality, is actually putting it together. So it's going to be f of x equals -x plus 1 when x is greater than or equal to 3, and x minus 5 when x is less than 3. We have another example to try. The process does not change. Can I change the screen? Okay. Yes. Good question. They both can't be equal. So we typically assign equality to the first piece. Say that again? Yes, we did. Okay. Let's really sound this into our head using our second example, okay? The process does not change. Piece 1. What are we going to do? Don't change anything. So f of x equals 4, parenthesis, x minus 1, plus 2. Distribute 4. What's my expression? 4x minus 2. How do I get piece 2? Negative 4 plus 2? Negative 2. What do we do for piece 2?
Good morning.
The opposite. So this will become negative 4.
Please stand for the pledge. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Students are reminded to be responsible by being on time and in uniform, to be respectful by treating others with kindness, and to be safe with words and actions. Have a day of excellence.
Do we match for our pieces? What is H? Careful.
1.
H is 1. So when x is greater than or equal to 1 applies to the first piece, x less than 1 applies to the second. Again, this will always be the right ray. It'll always be the right ray. It'll always be greater than or equal to the H value. So when I put these together, 4x minus 2, when x is greater than or equal to 1, because this is the right ray. And then negative 4x plus 6, when x is less than 1, left ray. And we can draw a quick sketch. This opens up. My vertex is 1, 2. So that increasing piece is for when x is greater than 1, the decreasing piece when x is less than 1. And rewatch this example to help out, okay? Homework tonight, there are 3 graphs and one real world I would like to see you try. The golf question we will do as a warm-up review on Monday. Nice job today. Please shoot me any remind questions on this homework assignment. And anybody who's coming to finish the quiz, please remember to come before you go to lunch. I will write you a pass. Good job today. Coming back. You're welcome. Have a great day, guys. Hi.
How are you?